Hello boys and girls, Mr. M.A.D. wanted to come to you with a little video on lesson quiz 8.5, which you discussed last time I saw you, which I believe was Friday. And this was a difficult lesson in that it requires a little bit of perseverance, a general understanding of M.A.D. and how M.A.D. and IQ are interquartile range differ. So let's take a look at these questions. Hopefully this could help you maybe understand it a little bit better, maybe find where your errors were, or best case scenario, reaffirm what you already know. Let's take a look. Such which value has an absolute deviation of 5 from the mean of this data set? We're looking for which one of these values is 5 away from the mean, which means first, no pun intended there, I have to find the mean of this data set. I'm going to try to chunk some of these together. I can add them in my head. 26 plus 14. The 6 and 4 give me 10. We already have 30, so that's going to give me 40. All right, the 28 and the 12. 28 plus 12. 10 plus 20 gives me 30. 8 and 2 give me 10, so that's another 40. And then I have, and I kind of covered it up here, I have that 35 in the middle. I'm going to put the 35 right here. Okay, when I'm calculating mean, I don't need to know, I'm going to put the numbers in order from least to greatest. Let's take a look. 0 plus 5 gives me 5. 40 plus 40 is 80. 80 plus 30, I believe, gives me 110. So I have 115. Now I'm going to take 115. That's the sum of those scores. I'm going to divide it by how many scores we added up together. 1, 2, 3, 4, and 5. We'll divide this by 5. 5 is our divisor. 115 our dividend. Going to put a decimal at the end and add some zeros just in case we need them. I'll put a multiplication sign here. 5 times nothing gives me 1, or whole number I should say. 5 times 2 will give me close to a product of 11. That gives us 10. I subtract, that's 1. Annex down the 5. 5 times 3 gives me 15. We now see that our mean, remember we can denote mean by an x with a line over it, is equal to 23. We are to find which one of these values deviates 5 from the mean. Well, if I were to do this, 35 deviates 12 away. That's not right. 26 deviates 3 away. 14 deviates 9 away. 28 deviates 5 away, because 28 minus 23 gives me 5. So there's my answer to the first one. Okay, let's take a look at the next one. Okay, Vivian surveyed bicyclists in her community. See the average number of miles they biked per day. What is the M.A.D. of her data set? What does this tell you about the number of miles biked each day by the bicyclist? Use the drop-down menu to show and explain your answer. Okay, first, again, we have to calculate the mean. I'm going to try to chunk some of these. 7 and 13 give me 20. 20 plus 10 gives me 30. 30 plus 10 gives me 40, so I'm going to put a 40 here. Alright, let's take a look here. 4 plus 3 gives me 7. A little 7 here. 12 plus 21, I believe, gives me 33. 33 plus 7, I know it's not going to be 3. 33 plus 7 gives me 40. Okay, the sum of all those miles the bicyclist rode would give me 80. But now I have to find the mean of those. And I believe, let's see how many cyclists there were, how many bicyclists there were. 1, 2, 3, 4, 5, 6, 7, 8. We'll divide that by 8. I have 80 divided by 8 gives me 10. The mean of the data set would be then 10. The M.A.D. of the data set. Okay, now that I have the mean, I need to now go ahead and take all those values. So 7. I'm going to put them down line vertically. 10, 13, 4, 12, 21, 10, and 3. I'm going to now subtract or find the absolute deviation. Remember, deviation is a fancy word for how far it is, how far it gets away from that mean. Now I'm going to find the distance. And we talk about absolute, meaning all these will have absolute, meaning they're not negative. You can't have negative distance. If I were to think about this, I could put those absolute value brackets around every single one of these, which lets me know that, hey, my answer will be positive because we're just finding the distance. Whoa, how my pen slide over there? We just need to find the distance that they are. Let's take a look and do some math here. 7 and 10 are 3 away from each other. 10 and 10 are not apart at all. 13 and 10, 3 away. 4 and 10, 6 away. 12 and 10, 2 away. 21 and 10, 11 away. 10 and 10, again, 0 away. 3 and 10, 7 away. Let me just double check this. That's 3, that's 0, that's 3, that's 6, that's 2, that's 11, that's 0, that's, okay, 7. Now, mean absolute deviation. So I found the deviation, but now I got to find the average of what they all deviate from the mean of 10. Let's go here. 7 and 3 gives me 10. 6 and 1 give me 7. 7 and 3 gives me 10. That's 20. 20 plus 2 gives me 22. I put the 2 up top. 2 and 3. I have 32. I have 1, 2, 3, 4, 5, 6, 7, 8. Same here. 8 bicyclists here, so I divide this by 8. I get an answer of 4. The MAD of the data set is 4. So the number of miles biked each day by the bicyclists varied by an average of 4 miles from the mean. Now, if we take a look, does that mean everybody is 4 miles from the mean? No. Look, we have 3, 0, 3, 6, 2, 11, 0, 7. Actually, nobody was 4 miles exactly from the mean, but it's the average, the mean. And again, if I take a look at the largest, the person who biked the most, 21 miles. They deviated 11 miles from the mean. Doesn't mean that the largest number from the mean was 4. We're talking average here, boys and girls. We take all values into consideration. All right, let's take a look at another one. Wyatt analyzed the data from his science experiment and found that the MAD was greater than the IQR. What does this tell you about the variability of the data? Remember, IQR we can't solve by finding mean. If I want to think about IQR, if I go back to that last data set, I'm going to take a picture of this data set right here. I'm going to post it to the other one. Let's just say that this, for some reason, is Wyatt's science data. Now, the nice thing here is we already know about the MAD. So let me clipboard this. We'll go next page here. Let's post this down here. All right, let's take a look here. Paste. Now, remember to do IQR. We need to find quartile 3 and subtract from it quartile 1. That gives us our IQR. That's the distance between the middle 50% of the data set. Now to find IQR, I have to put these numbers in order from least to greatest. So we have a 3, a 4, a 7, 2 10s, a 12, a 13, and a 21. 1, 2, 3, 4, 1, 2, 3, 4. All right, let's take a look. IQR, break this up. We have 8 pieces of data, so I have 4 in the lower half, and I have 4 in the upper half. All right, now to find that IQR, let's see, what's in between 4 and 7? Well, if I go up 1, I get 5. If I go down 1, I get 6. So this would be the quartile 1 is 5 and a half. That's quartile 1. Quartile 2, in between 12 and 13, is 12 and a half. Now this situation, the IQR would be 7, right? 12 and a half minus 5 and a half gives you 7. We already know that the mean for this would be, or the mean for this, I think, let's go back, I think the mean was what? What did we say it was? 10. All right, the mean for this was 10. And we know that the MAD for that data set was 4. Now, since the IQR is larger than the mean absolute deviation, it means we have a larger range here. We have more variability between there. If we have a small IQR, it means the variability is very tight. It means there's not a lot of difference between there. If we take a look here, it says here that the MAD was greater than the IQR. In our situation, the MAD was smaller than the IQR. all that tells me is that every number is pretty tightly aligned and there's not much deviation from the MAD and every value data set. When the IQR is smaller, it says, hey, you know what? That middle 50% of the data, half the people were tightly aligned. And because of that large MAD, but the smaller IQR, we want to say that the average variation is spread out more than the middle 50%. The middle 50% would be tightly aligned, whereas the average variation would be greater. Correct answer for this is B. The middle 50% data is spread out more? No. If the middle 50% is spread out more, it'd be our IQR that is larger than our MAD. It says the average of data is closer to the least value. And what we talked about, remember, just because one value is the least value and the greatest value, that's not necessarily a good indicator of how close that is to the MAD. All right, let's take a look at the next one. Natalia recorded daily visits to her website. The data for the first 9 days is shown below. Natalia is curious to know the MAD and IQR for her visitor data. Now, I think that IQR is easier to find out, so I'm going to find out the MAD first. I'll get the hard part out of the way. Let's try to combine these. Oh, actually, I need to write these down anyways. I'm going to put them in order from least to greatest because I'm going to eventually have to do that. Oh, look at that. They did it for us. So I'm going to go 6, 7, 8, 9, 16, 17, 18, and 19. All right. Now, if I do the MAD, let's do that. Let's go 6 plus 7 gives me 13. 8 and 7 give me 17. Hey, this gives me already 30. We have 16 plus 17. I believe that gives me 33. So that gives me 63. 18 and 19, I believe, give me 37. So that's 37. Hey, that gives me, I believe, 100. Let me just double check my math. 6 and 7 give me 13. Okay, 6 and 7. 8 and 9 give me 17. 8 and 9. 13 plus 17 gives me 30. Check. 16 and 17 give me 33. Good. That's 17. Alright, that's 10. Alright, good. Now, it says here, we have to find the MAD. Well, I have 100 divided by 9. 100 divided by 9. I could already tell myself that this is probably going to give me a decimal answer, which I don't like dealing with decimals. It's going to make it a little bit more cumbersome on me. So I'm going to have to be very diligent here. Alright, so divide by 9. Let's see, this gives me a 1, which gives me a 9. Subtract, that's a 1. Bring down the 0. That gives me a 1. I see something's going on here. It's going to repeat for what? Ever and ever and ever. Oh, you know what I just did wrong? I'm looking at the wrong data set. Goofball. This is the data set. These are the numbers I dragged down. How about I try that? How about we add these numbers instead? Bonehead, Mr. Giomini. Alright, let's try this again. 25. Let's put these in order from least to greatest. No wonder why they did a nice job putting these in order from least to greatest. Let's go this again. Let's go 25 is my first value for my data set. There we go. I need to wake up. 25. 27. Let's go 31. 33. Let's go 39. 41. 46. 48 and 52. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. They said 9 days. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 25, yes. 27, yes. 31, yes. 33, yes. 39, yes. 41, yes. Okay, good. Woo! That makes a lot more sense. All right, take a look here. 25 and 27 give me, I believe, 52. Put a little check, I use those. This gives me 9, 10, 11. Let's just go this. 33 plus 31 gives me, I think, 64. Let's put a check. Check. 39 and 41 gives me 80. Check. Check. 58, or excuse me, 52 and 48 give me 100. And then 46. So let's make that last one 146. 146. 146. Let's add those together. 6 and 4 is 10. 10 plus 2 is 12. 6 and 4 is 10. 18. 19, 24. 342. All right, let's try 342 divided by 9 days. That gives me, I believe, because 9 times 4 is 36, too big, so you go 3 here. That gives me, not 37, Scott, 27. Alright, that gives me, I believe, let's see, that's 7, annexed on that 2. That gives me 38. Alright, now, there's no answer 38. Oh, I got to find the M.A.D, meaning I have to find how far each score deviates from the mean of 38. So let's write minus 38 from these. Remember, we're doing absolute, so these are all going to be positive. We're looking for the distance between the two. Alright, we're looking for the distance between the two. Just think about how much shorter this video would be if I actually read carefully enough. Didn't pick the wrong data set. Alright, let's take a look. 13, 11, 7, 5, 1, 3, 8. That's not a plus sign. That should be a subtraction sign. There you go. Or equal sign. Getting sloppy here. That is 10, and this is 14. Okay, add all these up. 7 and 13 give me 20. Try to make 20 as much as I can, or at least 10s. 8, 1 give me 9. 9 plus 11 gives me 20. 5 and 3 is 8. Plus 10 gives me 18. 18 and 4. 18 and 14. How about 8? 18 and 14 gives me 18 and 14. 18 and 14 gives me 32. Alright, we have 3, 4, 5, 6, 7. We have 72. Divide that by 9. We have a M.A.D of 8. So on average, each one deviates 8 from the mean. Now, again, is the largest one 8 away? No. Is the smallest one 8 away? No. That's the average. That's the average. So don't get confused with when we get a M.A.D that's how far every number is. It's just the average. Now I have to find the IQR. Finding the IQR. We have all these numbers in order from least to greatest. I think we have an odd number of data. We have 9. 1 less than 9 is 8. Half of 8 is 4. So 1, 2, 3, 4. Lower half. There's quartile 2. 1, 2, 3, 4. There is quartile, or there's the upper half. We're looking for quartile 1, though that's in between these two numbers, in between 27 and 31. If I think about it, go up 1, we got 28. Go down 1, we have 30. 29 is quartile 1. Q1 equals 29. Now we're in between here, between the median of the upper half, between 46 and 47 is, or 46, 48, excuse me, is 47. 47. I subtract now. 47 minus 29. Their range is 18. Now, look at this. This is nice because now we see, hey, the middle 50% of the data from here to here varies a great deal more than the score each score does from the mean. This tells me that the middle 50% of the data has greater variability than the average variability. All right, that goes opposite of one question we answered before. Last question, and this ties in. It's nice. I believe these are all true and false. Hugh recorded the temperature at the same time each day for 1 month. He found that the M.A.D of his data set was 4.3. What does this expression tell you about the temperature that Hugh recorded? Choose true or false for each statement. The lowest temperature varied only 4.3 degrees. That's false. Remember, M.A.D is average, not the highest, not the lowest. On most days, the temperature varied about 4.3. That's true, because we're talking about on most days. We're talking about the average. No temperature varied more than 4.3. That's false. We go back to our previous question. Look at our M.A.D was 8. Did every single one vary 8? No. So going back. And then the highest temperature varied about 4.3. So that's also a false. There I have finished. 8.5. Look forward to talking to you guys more via this medium here over the next couple weeks. Hopefully I can see you before the school year ends. Don't know what's going on here. But we will continue to chip away and get better on a daily basis. All right, take care, boys and girls.